Alright, let me just get the thingy running. Ooh. It's hectic. Yeah, I don't know what's wrong with this thing. Rotates. But it's moving. Let's move. We're good. Good, good. Super. All right. I'm not going to waste more time because I need you guys to go and revise individually. So we're just going to make a few touch-ups, remind ourselves on things that we need to remember before tomorrow. Yeah, don't panic. It's not a difficult examination, and all the best. But let's do functions quickly. We did just go and remind yourself what we did when we first met. Remember when we first met, me and you guys? Yeah, last term, the end of last term, we're doing also functions. Number patterns are also there. Also give yourself time. Don't stress yourself. Do your best. And the rest will recover them in preparatory examination. Alright, functions, general functions, we have different types. We have linear functions, straight line, y is equal to mx plus c, those simple straight lines. Yeah, this one is the a is the gradient here, and then we have the quadratic function, also called the parabola. So this is the standard form that we use to check the plus, and this is the turning point format. And then we also have the normal quadratic function. This can also be written as ax squared plus bx plus c. You can also write this as a is equals to ax minus r1 x minus r2. Yes, this is the root format. And then we have the hyperbola. It's always in this format. And then we have the exponential function, which will also be used in the inverse function, but we can use any functions in an inverse function because we just substitute the value of y and the value of x. Let's jump straight into it without any further waste of time. These are what you're going to be tested with. 75% of the pay of your functions will come from this form. He will only contribute 25%. This will cost 75%. And then the examiner will try by all means next time to mix two at a time. But I'll show you. It can either get a linear and a quadratic, a linear and a hyperbola, a linear, maybe an exponential and a quadratic, but we will always pick two. So it's easier to take linear and quadratic, linear and hyperbola. But you know, sometimes examiners, they can just wake up and take 3 graphs, linear, quadratic and exponential at the same time. But you just need to have the skill to be able to solve that. And today is just to remind ourselves on what we have learned in the previous term and during our revision classes. Right, let us move straight into it. This is how you're going to see your graph. First question in functions, you'll see something of this nature. You will see a parabolic graph and a straight line, or a parabolic graph and an exponential hyperbolic graph. So you'll have two combination of the two. So here we have in one of the previous question papers, I see that we have a parabola and a straight line. And then let us check. I want us to take the information that is here and put it on the diagram, so we don't have to come back to the information this side. And the same way that we're doing in Euclidean geometry, doing our diagram analysis, let us take the information that we have here and put it on the diagram so we can always focus on the diagram. It's also going to save us time. Right. Are we still fine? Next. Yeah, because I want you guys to see the whole screen. Not for this one. We need to see the whole screen. It's not gonna be long. Just gonna teach you a skill and we go. Skill go. Okay, fine. Let's take a look at in the diagram below. We have the graph of f at x, ax squared plus bx plus c, which is our parabola. So we don't have the equation. We are not given the equation of this graph. So our f at x is just ax squared plus bx plus c. And then we have b and c, and then we have g of x equals to negative 4x. The equation of this line, y equals to negative 4x minus 12. We're taking that information from the diagram, from the statement. And then they are saying B and C are x-intercept. So B and C, they have been confirmed as x-intercept. So when you have an x-intercept, already we know that your y is equals to 0. Let me call it x2. I know here I have y that are equals to 0. Good. And C is the x-intercept of G. So B and C are x-intercept of F. And then C is also an x-intercept of G. So this is still the x-intercept of G. And then F and G intersect at A and C. So this is a point of intersection. That's where they are equal, those two functions. And then A is a turning point. You can just show that it's a turning point so that we don't have to come back there. It has been confirmed as a turning point. And then we have a line of x equals to negative 1 is the axis of symmetry of F. This is the line. So it means this will divide this line into two equal parts. So we know that your x here already has been given as negative 1. And then we will find our y in the instance we don't have a y over here. We haven't seen any questions. This is what we know. So your x equals to negative 1 this side, and then somebody will come and say, okay, Menier, but because I have x equals to your y being equals to 0, I can solve for the value of x there. But let us now go to the questions. This will help you to be able to activate your brain to start planning on how to solve this problem. Let's look at the first problem. The first problem will be, I don't know if this will go away. So we have these values. Let me just remove this. Yes, so let's look at the question. The question is saying, determine the coordinates of A, B, and C. So we're looking for the coordinates of A, the turning point, B, okay, good. So looking for the coordinates of A, B, and C. Remember, A is a turning point. You know that the turning point, B are your x-intercept, and for the parabola. And the parabola, remember, we don't have an equation for it. We know here we have x equals to negative 1 and y. So it's easy for us to do that because we have an equation of a straight line passing there. Y was equals to the negative 4x. Let me just go back quickly. Y was negative 4x minus 12. So I can get the y coordinates here for A. It was given that this is negative 1. So I can look for the value of y of A. So I'll use that equation of a straight line. So I have y being equals to the value of x is negative 1. So I have negative 4 multiplied by negative 1 and then minus 12. And then my y will be negative times negative is positive. So I just have 4 minus 12 and my y will give me a negative 8. So it means the value of point A will simply be negative 1, the coordinates, and negative 8. And as soon as you get any something, please put it on the diagram? Was it negative 12? Yes, it was negative 12. So we have negative 1 and negative 8. Please don't be alarmed. These diagrams are not drawn to scale. I know somebody will say, yo, negative 8 is that far. It's not drawn to scale. So don't judge yourself. And then let's look if we can find B. Remember we said B, we are told that this are the x-intercept. We know y is equals to 0. So we need to find the value of x here. We know y is equals to 0. Because the straight line is passing there, it's easier for us to find the coordinate of B. So if you find the coordinate of B, so we say we're looking for x, let's coordinate the x of B, and then the y is equals to 0. We're using the same straight line. I'm going to abuse that straight line. So where y is equals to 0, so 0 will be equals to negative 4x minus 12. Do we see that? And then negative 4x minus 12, we're going to transpose this to the other side and say 4x equals to a negative 12. If I move this, we change the sign, and then my x will simply negative 12 divided by 4, and my x will be equal to a negative 3. So my B, the coordinates are x equals to negative 3 and y is equals to 0. Digest that. Awesome stuff. Now that we have B, it will now become simple for us to find C, because we are told that this line is your line of symmetry where x equals to negative y. So we can use the line of symmetry to find this point, because we cannot use the equation of the parabola because we have a lot of unknowns. And then, or we can use the turning point format to do that, but the easiest way is to say, because even this one, you just need x of c and y is equals to 0. Line of symmetry divides a parabola into two equal parts passing through the turning point. So it means the distance from here to here must be equal to here from that side to that side. So I have x equals to negative 1, I have x equals to negative 3. So if I want to move from negative 1 to negative 3, I will move by 2 units. So it means even from here to here, I must move by 2 units. So I'm from negative 1, I move 2 units to the right. It means I will land where? My x will simply land me at 1. At 0. Because why? This line is a line of symmetry. And what is the equation of this line? X equals to negative 1. So from negative 1, if I want to move 2 units, so negative 1 plus 2 will just give me 1. So the coordinate that we have will actually be your negative 3 and 0, and then we will have 1 and 0 and negative 1 and 0. We still have the equation of that. And then let's take a look if we have another question. I hope it makes sense. Because it's just 4 marks. You get 2, maybe this one will provide you with 2 marks, this one will provide you with 1 mark. That one will also provide you with 1 mark, because they are implementing the same skill on both sides. Hope it makes sense. And then as you go in your diagram, write down those values. You see, I'll always be starting again every time, because as I move to the next slide, it gets. Oh, let me not quit it. Oh, I did quit. Never mind, it's fine. Let's just do this. when we remember, I think I'll always remember. Let's go to the next one. I had negative 3 and 0. I had negative 1 and negative 8. I had 1 and 0. That's all I've managed to calculate. All right. Now they're saying show that f at x. Remember, we said when we started, we said f at x was just ax squared plus bx plus c. And then they are saying show that ax squared plus bx plus c is equals to 2x squared plus 4x minus c. So I'm going, because we have a turning point and we have the intercept, I'm going to try it in two different ways and see which one is easier for you to understand. But you need to know both skills in case you have a different scenario that will actually force you to use that skill. Let's use the turning point. The turning point here was given as -1 and -8. That's our turning point. And then the equation of a turning point is of f at x will be ax plus p squared plus q. So your f at x will simply be a. We're going to have the value of a. We have x, and then we have a -1. It will change the sign. It will be a +1. If it's -1 here, then it's going to be a +1 that side, squared, and the q takes it as it is. It will be a -8. And then this is a. And then we need any point. So we can use one of these points. We have the 2x intercept. So I'm going to substitute -3, or use 1, where x equals to 1 and y is equals to 0. X equals to 1, y is equals to 0. So this is going to be 0 because this is y. Then a, and then x equals to 1. So 1 plus 1 squared minus a. So I'm substituting that point, substituting point C. Therefore, I can simplify the side. This will be 2. So 0 equals to a multiplied by 2 squared, which will be 4 minus 8. So 0 is equals to 4a minus 8. So a will go this side, 8 will go this side. So I'm going to have 4a being equals to 8. Therefore, my a being equals to 2. And once I've done that, I can go back and substitute it back there. Say my f at x is actually 2x plus 1 squared minus 8. Then I expand that. This will be f at x equals to 2 multiplied by x squared plus 2x plus 1 minus 8. So my f at x will simply give me 2x squared plus 4x plus 2 minus 8, and then my f at x will give me 2x squared plus 4x minus 6, which is what they want us to show. And then we can take a look at that and see if we understand that. And then let me see if I can use the space just a bit. If I use the roots format, yeah? So f at x will simply be a x minus r1 x minus r2, where r1 and r2 are your x-intercept. So your f at x will simply be a, then x, and then this will be plus 3 because it was negative. Remember it's minus r1, so it's going to be positive. And then this side, it is going to be negative x minus 1. And then you can also substitute 1 point here to say, okay, this will give me, I'm going to use this point. I'm going to substitute point C, A. Substituting point A, which is negative 1 and negative 8. So this is why it's negative 8. Then A, where I see x, I'll put negative 1. So I have negative 1 plus 3, negative 1 minus 1. So negative 8, which will be equal to negative 1 plus 3 will give me A, then multiply by 2, multiply by negative 2. This will be negative 4a. So a is equal to negative 4a. So my a will therefore be equals to 2. So I have this equation with my a now confirmed as 2. So my f at x can be written as a, which is 2, and then x plus 3, x minus 1. Then I expand this. This will give me x times x will give me x squared. X times 1 will give me negative x. 3 times x will give me 3x. Both of them will give me 2x combined. 3 multiplied by negative 1 will give me a negative 3. And then I multiply everything. This will give me 2x squared plus 4x minus 6. So whichever way you would like to use, you can use that, because fortunately enough here you had the x-intercept and you also had the turning point. So then it was very difficult for you to actually not get that equation, especially when it's given to you. So it was just the examiner being very happy on that day and just showering you with a lot of marks. Hopefully it will be the same situation. Hopefully. But once you are prepared, we will be okay. Alright. Just 32 minutes and then we're gonna move to the next one. All right, I'm gonna rewrite them again. This was negative 1, negative 8. This was 1 and 0. This was negative 3 and 0. The equation was y equals to negative 4x minus 12. The equation this side was f at x being equals to 2. I can write it as a turning point format because I like it. It's x plus 1 squared and then minus 8. Somebody can also write it as f at x 2x squared plus 4x minus 6 as it is given in our 5.2, né? And then Write down the coordinates of the turning point of f at x minus 3. So what is actually happening here? It is not the same. It's not the same graph. Do you see that the graph has actually been transformed? There's transformation that actually happened here. As soon as you subtract 3, it means you are moving the graph to the right. This graph has been moved to the right by how many units? By 3 units to the right. And it has moved down by how many units? By 2 units. So when I have it on my coordinate format, I know that I have this point, and then if I move this point 3 units to the right, the turning point will now be, if I move 3 units to the right, it will just be 2, yeah? Because I have moved 2 units to 3 units that side. So it's going to be -1, and I'm going to just add a 3 on it, and it will give me a 2. And then I'm going to move 2 units down. So I'm going to move this 2 units down. When I move down, it will just be a -2. So the new coordinate will just be a -10. No need for a lot of calculation for this one. Just have to interpret what you actually got. So that, hence I like to always keep my function in turning point format. But this one, even the format was not necessary. What was necessary was you knowing the turning point, which one of the questions that you are supposed to answer. So knowing that every time when you subtract something from x, you are actually moving the graph to the right. And if this was plus, we're going to move the graph to the left. You also need to be able to be versed when it comes to such problems. So this is the new turning point. Yeah, the old turning point of f at x was -1 and -8. So we moved 3 units to the right, 2 units down. And then let me write down this problem, né? So I don't have to so I don't have to redraw the coordinates. It says write down the value of k if f at x equals to k, has equal to, we can interpret this in so many ways, and I want others to adopt the most simple one. Good. Remember we said f at x equals to y. Can we write this as y so that it can make sense to you? So we have y equals to k. So y is just the y is just f at x equals to k is just a straight line, and this is a constant. So we are expecting to have a line that is perpendicular to the x-axis. So we are saying, write down the value of k if f at x equals to k has equal roots. Remember, for it to have equal roots, it means your f at x must be on top of it, touching it once in the parabola. For it to have equal roots, b squared minus 4ac must be equal to 0. Or we can understand it in terms of the turning point. So if this is my y equals to k, this is my equation y is equals to k, and then this is my parabola here, it must touch it only once. So here I am, I want to find out the value of k. Let us see if I can move this by graph this side. Right? If I have a straight line, this is my y is equals to k, here's my y is equals to k. I'm going to move the straight line. I have a ruler. Is there a solution? Does this graph and this graph touch anywhere? There is no solution here. If I take this graph, y equals to k, straight line. It touches how many times? It touches our graph twice. So we have, for this one, we'll have two roots. One being positive goes on the positive side, one being negative. But look what happens when we put it in a turning point. It has how many roots? Only one root. And in a quadratic, once we have one root, it means that those roots are actually equal to each other. Your discriminant is equals to 0. So it means that the value of k that we actually want is y is equals to, then we look at the y coordinates of the turning point, because we're looking for the y value, which is what? Y is equals to -8. Therefore, we can say k, u must be -8. And somebody can also interpret it and say, but why don't I just call this line the x-axis? Let me call the x-axis y is equals to k. And then let me take, instead of moving the straight line, let me move the parabola. So if you move the parabola, for the parabola to actually touch the x-axis only once, that means you need to move it up. By how many units? Because already it is at -18. So you need to move it up by 8 units. Hence we are going to say your k must actually be equals to -8. Because it's supposed to move up by 8 units. I hope that I make sense, because this graph will move up. Because once I say, and then when you move the parabola, it means that the k must come this side. So your f at x minus k will start being the movement, which is equals to 0. And then if we're to find the equation where maybe that one is too much without any interpretation, to say, if now I move the graph up, remember you had your f at x being equals to 2x squared plus 4x minus 6. So for you to find a discriminant, you must have a 0 on the other side. So you had y is equals to k. So now you will have 2x squared plus 4x minus 6 equals to k. We take k to the other side. You have 2x squared plus 4x minus 6 minus k equals to 0. So you want your discriminant to actually be equals to 0, which is the long way of finding it using algebra. So your b squared will actually be 2. So we'll have 2 squared minus 4. What is a? B squared is actually 4. 4 squared. Let me fix that. because this will be our b. How do we get it via algebra? So we have 4 squared minus 4, what is 8? 8 equals to 2, and c will now be negative 6 minus k. Because the whole thing will now be c. And this must be equals to 0. So we solve this, we have 16 minus negative 4, it will give us negative 8, negative 8 times 4 will be, is it 48? Let me make sure. So we have 4 multiplied by 2 multiplied by 6 is 48, a positive 48. And then we have a positive, this multiplied by this will be 8. And then this will be another positive 8k. And then let's take this to the other side. We have 16 plus 48. We get 64. And then 64 will be equals to plus 8k equals to 0. And then when you simplify this, this will say 8k is equals to negative 64. Then we divide both sides by 8. We divide both sides by 8. So our k is simply negative 8. So you must also be very careful. Né? Because you are moving the parabola. Once you must start moving the parabola, you must also know that the sign will change because it will now be on the other side. So you see, you get the same value, or you can easily interpret it using logic to say, but they are talking about f at x equals to k. F at x is the same as y is equals to k. So I have a straight line that is called y is equals to k. Let me see where does it touch the graph once, depending on what the question is saying. Where does it touch the graph twice? So if it touches the graph twice, you know it has 2 unequal roots. If it touches the graph once, you know that it has 2 equal roots. Né? If it's twice, it's 2 unequal. If it's once, it's 2 equal. If it doesn't touch at all, there is no solution. I hope that makes sense. So algebra will take you longer, but you will get there. But I would advise you to just be able to say quicker. And then let me save this so that we can go to the next question. The next question says, let me write this. Turning point is one of these important because we're looking for the range. Remember, the range is the y values where this graph exists. Domain is the x values. So we're not looking for the range of negative f at x. So it means that once you put f has actually flipped. So this negative 8 will now change and become a positive 8. So we're going to have a graph of this nature. Undo. Let me just. We'll still be here. We'll have almost a graph of this nature. This is us making assumption, interpretation. So we'll still have a negative 1 and a negative 8, also and a positive 8. Because what changed is only the y value. Whatever which was positive has now changed and it has become positive. So that's the catch because it's the negative f at x. So y will be the element of, now this will be a local maximum. It's a maximum now. So it will start from 8 and go to negative infinity. So somebody can also say y is an element of, and then y is less than or equals to 8. That's for f at x. But the range for f at x, we know very well that the range for f at x was y is an element of from where? From negative 8 to positive infinity. Because the graph is actually concave up, it's going bigger and bigger. Or another way of writing it would be say y is an element of, and then y must be less than, y must be greater than, not less than, y must be greater than or equals to negative 8. Why is this included? Because it is a turning point, it's part of the graph, so we must include it. You cannot exclude it because it is part of the graph. So that's typically what we get when you have a straight line and a quadratic function or a parabolic function. And then I'm going to write the points again. This is critical thinking questions. It says that if f plus 4x minus 6, determine the length of OT. Determine the length of OT. If PRT is perpendicular, which is also shown, to the x-axis. With P as a point on F and R is a point on G, and PRT is equal to 16 units. Now I want us to try two different things. I think we have the coordinates here was -3 and 0, and then we have the coordinates here, which is what we are going to find, x of r, y of r. So we have two equations we're going to find using the point of interest, because we see a right angle triangle. You see that? I was given, if I get this coordinates, I'll be able to, if I get this coordinates, I'll be able to find the distance from here to here. I'll be able to find the distance, the coordinates of this one. I know the coordinates of this one, x, y already is 0. The same x will be the same, because they're perpendicular. So the same x that I get here will be the same x this side. This is 0. So I'm able to find the distance between this and that. And then once I find the distance between this and that, this is very simple. It goes from 0. I know this coordinate is -3, so it's just 3 units from here to here. But let's try it. Let's equate the coordinates. I will try it with different ways. There are different ways of actually answering the same problem. I have two equations. The equation of this guy was actually f at x equals to 2x squared, which is also given there, plus 4x minus 6, and then y was equal to -4x is minus 12. Good. I'm going to equate the graph so I can get what's happening here at the point of intersection of those two. What is actually happening there is that we have 2x squared plus 4x minus 6 is equals to negative 4x minus 12. I'm equating the two, and then I'm going to simplify and see how much do I get. Take everything to the other side. I'm going to have a 2x squared plus an 8x. This has come this side. It's going to be an 8x, and then minus negative 6. I transpose this to the other side. It will change the sign, so it's going to be a plus 6, which is equal to 0. Please do verify that we are giving the same values. Then this is equal to 0. And then we can divide everything by 2 there. I have x squared plus 4x and then plus 3 equals to 0. So things becomes easy for me. I have x minus plus 3, x plus 1 equals to 0. So your x equals to negative 3, or your x equals to, no, there's no point of intersection, your x equals to negative 1. So I made a mistake this sign because I thought this was the parabola was not passing there. So our point of intersection is not there. So let's discuss that method. Okay, fine, it's good. So what I will do now, because that one didn't work, I will look at the distance here, which was given to me as PRT. It was 16 units. Let's discuss that. So this only gave me the turning point. Right? The point of intersection is here and here. So I can't go through that route. So good. But it's not a train smash because now I still have this point. So my curve here, and if I were to have a line here, my line would be y equals to 0, right? The equation of the axis of symmetry is y is equals to 0. So if I want to find a distance between two functions, I need to subtract them. So if I subtract f at x minus my y, it must give me 16 units, which is what they gave me here. It will give me 16 units. So my f at x is actually 2x squared plus 4x minus 6. Remember, y is equal to 0. The x-axis, the equation of the x-axis is y is equal to 0. So I subtract the y values because this is just the y's, right? So which is minus 0 must give me 16, which was given to me as 16 units. And then this will be 2x squared plus 4x. Transpose this to the other side. I think it's going to give me a negative 24 equals to 0. And then let me divide everybody by 2. I have x squared. Then I have 2x. Then I have a negative 12 equals to 0. So my x will actually be, if you factorize this side, to get 2, it's going to be negative 24. We have 3 times 4. We have 6 times 2. And then what else do we have? 8 times 3. No. 6 times 2, then 12. Times 1. Which other factors do we have that I forgot? Am I having a brain block? So this will be factors. You know, I wish you were here. You know? What's the other one? Because this one will never give me 2. So it's divide by 2, 12 divided by 2. So it's 6 times 1, 4 times 3. Factors of 12. Am I getting 32? It's negative 6. Oh, negative 6 minus 16. It's negative 22. Let's fix that. Let's fix this. Sorry, guys. And yeah, I see that something is not right. All right, it's 2x squared plus 4x minus 16. So we have 2x squared plus 4x, and then this is negative 22, not 24, equals to 0. And then I divide both sides by 2. I have x squared plus 2x, and then minus 11 equals to 0. Then you can use the quadratic function here. X equals to a negative b plus minus the square root of b squared minus 4ac all over 2a. And then my x will simply be, let us calculate that. Negative b will be a negative 2. And then b squared is 2 to the power of 2 minus 4. A is 1, then c is negative 11. Then all over 2 multiplied by 1. Good. Let's see how much we get. What is my A? My A was 1. And then my C was negative 11. Divided by 2. I have x equals to 2,46. And the other x minus 8. And then x equals to negative 4, 464. Good. You cannot pick the one that is positive here. You'll pick the one that is negative, which is on the side. So this point will actually be at negative 4,46. That's x. So therefore, if now they look for the distance of OT, the distance of OT will just be 4,46, moving from here to there, because that's your OT. Please let's check that one out. Erase this one. I'm going to leave this one here because I thought maybe the graph was, this function was actually passing there. So that was my mistake aside. I was going to use it using the point of intersection, then using it to find that point, and then it didn't work. So what we get is that the distance will just be, remember distance is positive, so it will just be 4,46, because moving from negative 4,446 to the point of origin is 4,46, and they're looking for the value of OT. Please check that one. That's an interesting problem. Good. All right, device is off. Let's go for an ad break. All right. I was trying to look at it and see if we can find another way of doing it. Yeah, no. No, it's okay. With this one, we are having a combination of an exponential graph. So you should not be intimidated by these problems. Eh? Just know what you are given. So we have an exponential graph, and then we also have a hyperbolic graph. So we have two different graphs, and you are also given that the asymptotes of G, they are given as x equals to 2, y is equals to 1. Asymptote of G, remember G is your hyperbola. So we have x equals to 2 and y is equals to -1. Yeah, there we are. X equals to 2 and y is equals to 1. This is your point of symmetry. You have your point of symmetry, and then the asymptote of f is y is equals to 1. So they are sharing this asymptote. Y is equals to 1. So just by having the point of symmetry, let's go and fix that equation. That equation of G will now be G of x equals to A, and then x, because 2, this will be a -2, we agree. This will be a -2, and then our C will simply be just 1. We don't have the value of A yet, but we can always find the value of A. This is what we know right now from the information that is given to us, without even looking at any of the question. So we have G of x, where x minus p plus 1, and then because the exponent, you must always check, even in the parabola, in a turning point format, when you have a turning point coordinate, when you put it in the equation, it changes the sign. This one was positive, it will now be negative that side. Fine. But the y, you take it as it is. Ne? Y doesn't. And then the next question you say, determine the equation of G. If the question was to say, determine the equation of G, I will then come and say, all right, let me do this. Let me see if I'm able to. Let me do this. We want to find the equation of G. So we've agreed that G of x is equal to A over x minus 2 and then plus 1. Why? Because our point of symmetry was actually 2 and 1, which is this point. So we just need to go and find the value of A, then we're going to look at where your hyperbola is actually passing. You can't take anything from the asymptote, your graph doesn't touch here. Yeah? So we're going to use this point. That's the only point that we have. X is 3, y is actually 4. Then you substitute that. X being equals to 3, y being equals to 4. We have 4, a, x3 minus 2 plus 1, and then your 4 being equals to a over 1 plus 1. So a plus 1 equals to 4. So a transpose this to the other side is just equals to 3. So our equation will simply be g of x equals to 3 all over x minus 2 then plus 1 becomes our equation of that hyperbola. Let's see, for interest's sake, if they can say, let us go and find the values of P and Q. If we're to be asked to find the value of P and Q, I think one of the most important points that we can have is if the asymptote is actually 1. Remember, when you have a hyperbola, x will actually be 0 here, and y will be 1, because anything raised to the power of 1 to the power of 0 is 1. So let us see if that's equals to q, and we say, let us go and find, let me make space actually. Let me make space so that you can also see the question. Eh? I think this one is also fine. Look. Let's talk about what we know about the exponential format. Determine the values of P and Q. Where is P and Q? When you look at P and Q, it's there by the exponential graph. So your f at x is equals to 3 multiplied by 2 x minus P plus Q. So what is happening is that we know that if we have the asymptote, your asymptote will actually be your Q. So your f at x is 3 multiplied by 2 to the power of x minus P and then plus 1, because your asymptote is your Q. It's both Q here, it's also Q in the side. So it's C and it's also Q. So now we have the value of Q. Q is equals to y, because that is the asymptote. Exponential functions, they have one asymptote. And then let's see if we substitute that point, because the exponential function also is passing through that point. That's the only point that we are actually sharing between the hyperbola and the exponential function. So your y is 4 and your x is 3. So I have 4, 3 multiplied by 2. What is my x? My x is actually 3 minus P plus 1. This comes 4 minus 1 is 3, so I'm going to have 3, and then 2, 3 minus P. Right? This multiplied by 3, and and then I divide by 3 on both sides. And then I have, let me just write 2 to the power of 3 minus p will be equals to 1. And then we say anything raised to the power of 0 is 1. So let's make them to have the same base. 2 to the power of 3 minus p is equal to 2 to the power of 0. Therefore, 3 minus p must be equal to 0. Because they have the same base, they must have the same power. Transpose this to the other side, our p is equal to 3. So if they say find the equation of f of x, we say my f of x will simply be 3 multiplied by 2, and then I have x minus 3 and then plus 1. That is your equation of f of x. Hope it makes sense, né? And then I will not leave without addressing this ones. Hope this makes sense to everyone. And even those who will be watching later, I hope it will make sense. Use what you have. Use what is given to you. Know the general equations. Know what asymptotes represent. And then you also need to know what happens at the x-intercept, what happens at the y-intercept, what happens when you have your intersections. Yeah, and then for this one, like I told you, we don't want you to use algebra on these problems. We want you to, in actual sense, mark the graph. This will be addressed by you knowing this. We need to know this. How you perform on this problem will be determined of how do you understand a positive multiplied by a negative. It's a negative. A positive multiplied by a positive. It's a positive. And then a negative multiplied by a negative. It's a positive. And a negative multiplied by a positive is equal to a negative. Your knowledge of this will help you solve that. And then let us now look at what we are having there. This is saying for which values of f at x. For which values of x is f at x less than or equals to g of x. Specifically for this one. This might not help you for now, but specifically for this one, we say we're looking for where f at x is smaller than g of x. G of x must be bigger, f at x must be smaller. So if I'm bigger than you, it means I'm on top of you. So we're looking for a point in our graph where our g of x is on top and then our f at x is below. Where do we see that in the graph? We come and check the graph. Take a ruler. You'll be having a ruler in your examination. Take a ruler. If you put a ruler on a straight line, you will see that if I take a ruler and I put it on this straight line, who's on top between the two? Remember, this is F. Let me mark it. This is F. and then this is G. What is my target? My target is that I want a portion of the graph where my g of x is on top. Where my g of x is the red one. Here you see that no f at x is on top, but I want g of x to be on top. You move with the ruler, you are moving with the ruler, you move the ruler, you see that every time, when you get here, things change. Look at what is happening here. If you draw a straight line, this side, remember, this will go until. So the red one is now on top. Do you see that? So you start to say x is an element of, things start being interesting here. What is the x coordinate here? The x coordinate is 2. The y coordinate, even if it's not going to help us, let us write it down. The x coordinate is 2. So we cannot include it because if the asymptote, other graph doesn't exist. This graph doesn't exist. So immediately after the asymptote, just a bit, we don't include that asymptote. We move, you see it's still until we get here. When we get here now, we see now the blue, which is f at x, is on top again. So it means the error ends here, the error ends there. So x equals to 3. And they said that it must be included when they are also equal. They're equal this side, so you include that 3. So your x is between 2 and negative 3. The other format, somebody can say without any calculations, by just interpreting the graph with your ruler. So as soon as you see f of x less than g of x, you know that the one where the big mouth is must be on top. The one where it's smaller, the mouth is smaller, must be at the bottom. You look for that in a diagram, and then you answer the question without any further waste of energy. But if you were given this, f at x multiplied by g of x must be less than or equals to 0. You know that you'll be looking for a combination of the two graphs where, because this simply means we are negative or equals to 0. So you're looking for a combination of signs where we have a positive and a negative, or a negative and a positive, because these graphs are multiplying each other. So there's, as I'm saying, this will actually help you to figure out when you have problems of don't get any other problems, but I want to at least by 5 we should be done, and so that you can go and study. Let's move. The next question. The next question is saying, let me the next question is, we had 2 and 1. No any other points to determine the equation of the axis of symmetry. Remember, the axis of symmetry are those two lines that will pass through the point of symmetry. The other one will have a positive gradient, and then the other one will have a negative gradient. We call them the lines of symmetry. You only talk about those two lines of symmetry when we have a hyperbola. You have only one line of symmetry when you are dealing with a parabola where it's passing through the turning point. This one is passing through the axis of symmetry. And so we have to determine the equation of that axis of symmetry of H for when M is actually less than 0. But there's a catch. It is not for this graph. It's for the graph of h of x. And then the graph of h of x is equal to gx plus 2. So what we are doing is that we are just moving the graph 2 units up. So it means that point of symmetry, let me call it point of symmetry, will no more be at 2 and 1. It will now be at 2 and 3. This point will be at 2 and 3. And I told you that the lines of symmetry depend on the point of symmetry. So we are looking for the one which has a negative gradient. So once we have the point of symmetry, we are fine because he just moved the graph 2 units up. So it means the y coordinate is the one that has been affected, which went up by 2 units. So our equation will be y is equal to negative x because we're looking for the one with the negative gradient, then plus c. And then we can simply substitute there to say x equals to 2 and y equals to 3. So I have 3 equals to negative 2 and plus c. This will come this side, so it means my y will simply be, my c will simply be 5. Yeah? Your c will simply be 5. So y will be negative x plus 5. That's your equation for the axis of symmetry. Remember there are two. There's the one with the positive gradient and the one with the negative gradient. The one with the negative gradient, the gradient will be negative 1. The one with the positive gradient, the gradient will be equal to 1 always. Don't forget that. Alright, let's see what we have next. I think now you are becoming refreshed a bit. Getting exposed to such problems is very important. And then, yeah, let's write down the equation of the asymptote. Let me check if you are still online. That's still visible. Alright, with this one, write down the equation of the asymptotes. We are having a different combination now. Do you see? We now have a combination of a hyperbola and a straight line. We had a parabola and a straight line, and we had an exponential function and a hyperbola. Now we have a hyperbola and a straight line. So hyperbola has been the famous person for the past 3 years. Hyperbola and allograph. So we're expecting something hyperbolic to come through. So your f of x will be equal to 2 over x minus 3 minus 1. They say write the asymptote. It's very important to say your x must be equal to 3, number 1. Those are your vertical asymptotes. And then the horizontal asymptote, your y will be equal to negative 1. Here is this thing of change. To say the y asymptote, the q goes as it is, What changes is the x, for a parabola and also for a hyperbola. Just remember that. So that's all we wanted. And then we also have write down the domain. Write down the domain of f. Remember, domain is those are x values. So when you are looking for a domain, remember you had asymptotes, where your x equals to 3 and your y was equals to -1. So your domain for a hyperbola, x is an element of, and then x, you can say x is an element of all real numbers, but x must never be equal to 3. And then for the range, y is an element of all real numbers, but y must never be equal to -1. Why? Because these two, they are asymptotes. So all the values in a hyperbolic functions, they do exist except the ones where the asymptotes are. So this will simply be the one that is answering our question, that our domain is that x is an element of all real numbers, but x must never be equal to 3. Straightforward question. Let's take a look at other ones, see what the other question will has for us. All right. The next question is a very interesting question. Determine the values of D and E. Remember, D and E are part of the straight line. Determines the values of D and E. So we have to look for the gradient, and you also have to look for the C, which is the x, which is the y-intercept. This is it. So they're saying determine the value of D correct to nearest integer if the graph of G makes an angle of 76 with the x-axis. X-axis. Maths is math, so they're bringing an analytical geometry into this, and this is now becoming our angle of inclination, where m will be equal to the tan of theta. This is our angle of inclination because it's making it with the x-axis, and it's actually, do you see that? So it means that our gradient will be the tan of 76, and our gradient is equal to b. So when you press it on a calculator, it will give you the tan of 76, which is 2,5. You can just say 5/2. And then they're saying to the nearest integer. So it means that D is approximately 3, because 2,5 is very close to 3. And our answer was actually, in actual sense, was 2,53. So yeah, it's close to 3. So I have now my equation of g of x. G of x is equals to 3x plus e. And then I look at what other point is e is g of x passing at. I cannot use this one because I don't know what's happening. I don't have any coordinates here. I'll definitely use b because I have x and I also have y. So I'm going to substitute very quickly to say this is my x value. My x value is 3 and my y value is 6. So g of x represents y, so I have 6 equals to 3 multiplied by 3 plus e, then this is 9. So we have 6 minus 9 equals to e, and then my e will simply be my -5. 3, which makes sense because here you can see it is passing there at a negative value. So my g of x is equals to 3x minus 3. That's the equation of this straight line. Y is equals to negative 3x, or positive 3x and then minus 3. Straightforward questions. Hope it makes sense to everyone. And then let's take a look at another one. Let's save this one. Same thing that we saw. We're saying g of x. So I want from today not to be intimidated by this. I know we did this. F g of x must be greater than f of x. Stop interpreting it to make it difficult for yourself. If you look at the amount of the inequality, this one is bigger, so I want it to be on top. If you are bigger than me, you're on top of me, and this one must be below. And then you go to your graph. Strictly your graph, you can take a ruler and say, okay, I want my g of x. Where's my g of x? My g of x is a straight line. Let me mark it in blue so it can be easier for us. That's my g of x. So I want blue to be on top, and I want red, we make it red, to be below. So anything that is f at x, I'll mark it as red. And then you'll be having a ruler, so you can come with the ruler from the left hand side to the right hand side, and then in your head, remember, you want blue to be on top. You look here. If you extend this blue line, the red is on top, né? Red is on top, red is on top, red is on top, and then come to this point. That's where they are actually equal. That's where things are going to start being recorded. So we start saying x is an element of, and then you have to know what is this point. At this particular minute, we don't know the value of that point. So we can go and find the value of that point. What is this point? That's our point of intersection of the two graphs. We have the two equations. So what we can actually do is to say, all right, I have 2 over x minus 3 minus 1 equals to 3x minus 3. Those are the two equations, remember. Remember the equation of a straight line was y equals to 3x minus 3. This one is complete. So our point of intersection, remember, that's where the two graphs are actually equal to each other. And let us see if we are able to solve this. Let's take this to the other side. I have 2 over x minus 3. 1 goes that side. I have a 3x. And then this will be a minus 2. Good. And then I have a 2 being equals to, you can decide to cross multiply this. And then this will give us 2 equals to 3x minus 2, and then x minus 3. And then 2 will be equals to 3x squared minus 9x minus 2x, and then plus 6. And then we simplify this very quickly with 3x squared minus 11x, and then 2 to the other side, it will give us 4 equals to 0. And then quickly we can do b is equals to negative b plus minus the square root of b squared minus 4ac over 2a to find the value of x, and then let us see how much it will give us. And you can substitute that and you will get your answer. So I'll just tell you what you're supposed to do next. So f at x will be b, and then b squared is negative 11, sorry. Negative 11 squared minus 4. What is A? A is 3. And then what is C? My C is actually 4. And then all over 2 multiplied by A, which is 3. And then you get two values. And then it means that from there, then that's where your x will actually start. Let's see if we cannot have any other way to find A, because of the information that we have and the information that we got. We have no other way to find. So it's going to give us two values. So let's say, for argument's sake, this was actually 1 when x equals to 1. So it means our things will start where x equals to 1, where we are including it, and then you move. Remember now, what is happening? You want the blue one to be on top. Blue is still on top. Blue is still on top. But what happens here? That's another point of intersection between the straight line and the asymptote. This graph doesn't move. So you will write the x coordinate there, which is 3, but you will not include it because why? The other graph doesn't exist. So it means that the blue is on top from here until we get here for this part. So it's from when x equals to 1 until when x equals to 3. And then when we move forward, you see the blue now is at the bottom. The blue is at the bottom, but immediately after that, if we can make a straight line, you'll see the blue will be on top again. So you will have that point of intersection. That point of intersection will also be found from you when you put in your quadratic formula. Probably, let's say for argument's sake, it was 4. So your other solution will be x is an element of from 4, because they are equal there, until it goes to infinity. We can say x is greater or equals to 4. So I think there must have been a question that says, let us find the points of intersection A and C, because it will not be 3 marks for so much work, but you need to have these points before you can answer this question. So I'll also check if maybe I skipped one question. Let me see this quickly, if there's any question that I actually skipped. No. Okay. All right, grade 12. And let us now take a look at Let's take a look at this one. This one doesn't have questions, so I didn't take out any questions from this problem. I want us to, because we have done an exponential one, we have done a parabolic one, we have also done the straight line one. This one is very unique. Ne? It has a hyperbola, it also has a straight line, and it has a parabola at the same time. So I want us to interpret what was given to us. And we have the graph of g of x, which is ax plus r. And then we have f at x, which is equal to x squared plus q. They are sketched below. Therefore, we have a line h of x, which is equal to x minus 1. So here's the equation of the straight line. At least we know something about the straight line. It's actually hyperbolic, né? Because we have two of them. So we have y is equal to x minus 1. That's the equation of the straight line. Let me just move things. Move. Like that. Move. Okay, y is equal to x minus 1. So we have point A is the x-intercept of G. So what is G? G is the hyperbola. And then A and B are the points of intersection of G and H. A and B, let's see, what's B? B. I don't see. Oh, there you go. 2 points of intersection, and the axis of symmetry of F intersect at A. The axis of symmetry of F, axis of symmetry of F, here they are. This is a point of symmetry, this one. Eh? And then we have C is the turning point of F. This is the turning point. You can write it as a turning point. And D, a point on F. D, a point on F, is the point of intersection of the asymptotes of G. That's point D. That's where parabola is touching the asymptotes of G. So let's go and look for its problems, because I think it's very interesting. Let me just quickly give it a few minutes and find the problems, the questions. So it says, the first question says, determine the coordinates of A. It says, let's go and find A, determine the coordinates of A. We have this point, and then we only have this point, and then we have to find the coordinate of A. Let me just give you a few minutes, drink water, and then let's think about how can we find the coordinates of A. I guess the 12 or 11.
He's very interested in this. Like the 12 maths. This is our top scholar right now in grade 11.
Yeah, it's but this is grade 11. Same thing. It's not similar, it's the same thing.
But you did that. Wait, so what is his name? Because we never got his surname. Or like what we focus on. We never got his name.
Nduku. NDUKU.
Nduku.
NDUK. Oh, okay. Look, none of these graphs will help us. The only equation that we have, if we're going to find the coordinates of A, is this equation of a straight line. And then it means that we know very well at A, what's happening is that it's an intercept. Ne? So your X, we don't know, but your Y we know for sure, it's actually 0. So for us to find A, we're going to use the equation to substitute Y equals to 0. So we're going to have 0 equals to X minus 1. And then your X will simply be 1. So you have found the coordinate. So your A is actually 1 and 0. And after you get these points, please do come and write them in the diagram. It makes the diagram much easier to understand. And then, yeah, that was a very 1-mark question. And then show that the coordinates of D is given as negative 2 and 3. So they're saying we must show that D is negative 2 and negative 3. The first thing when you see a question like this, you must go and check what's happening at D. Why are they so interested in D? Let's come and look what's happening at D. Here is D. D is a lot of things, right? D is the coordinate of it is the coordinate of your point of symmetry, né? Which has the 2 asymptotes. We don't know anything about the 2 asymptotes. And then this has also given us a clue to say this is our point of intersection of the 2 equations, but we don't have any of the variables in those equations because we have f at x equals to x plus p squared plus q, and then we have g of x equals to x plus r. So I want to ask you something. The line h of x equals to x minus 1, we said it was an axis of symmetry of q, right? And then we said if you're looking for the axis of symmetry, you will have y is equals to x plus c, and then you will substitute the 2 points to find c. You substitute the 2 points to find c. So we really need to find this point. So we will say, all right, if we didn't know this, if we didn't really know this point, because this is a point of symmetry here from this graph to this graph. So this, in actual sense, because it's a point of symmetry, it means the distance from here to here and the distance from there to there, they are actually equal because it's a point of symmetry. So why don't we use the midpoint and see what's going to give us? And then the midpoint of AC, A or AB, would be, let's start with the x coordinate. It will be, I have these 2. You have x is equal to negative 5, and then I have 1, and I divide it by 2. Because it's a point of symmetry. And then for the y's, I have negative 6 plus 0 divided by 2. So the midpoint of AB is simply 5 minus 1 is actually negative 4 divided by 2. This gives me negative 2. And I see that I have negative 2, so I become excited. Then negative 6 divided by 2 gives me a negative 3. And I'm sorted. How did this help me? Understanding the concept of symmetry. You say, if you are saying this is a line of symmetry, or this is a point of symmetry, it means that if you are at the 2 points that are the same on the 2 sides of the graph, they need to be the same distance from each other, or they're actually the mirror image of each other. So this, if you had this, and you have to fold this graph here, this part will be on top of this one. So this D is also a midpoint for the same point that are touching the two graphs, as long as it's passing through the point of symmetry. So we also need to also understand such concepts. So MAB, so we have shown that D in actual sense is -2 and -3. And then I think the other question was said, determine the equation of G. If we're to find the equation of G, where is G? There is G. As soon as you get the point of symmetry, everything becomes simple, because once you have the point of symmetry, it means your x is equals to -2 and your y is equals to a -3. So the graph of g of x will be equals to a. You must just go and find a, and then you have x plus 2, the x asymptote, and then the y asymptote goes in as it is. And then you go and substitute. Find any point where this graph is passing. Can take in any point as long as the hyperbola is passing there. We have one point where the hyperbola is passing, we have another point where the hyperbola is passing. This one is easier. So I'll take this one where x equals to 1, y equals to 0. So I'm going to substitute here and say, let me just substitute here, y is equals to 0, I have 0 equals to a over x, x was 1. So I have 1 plus 2 minus 3. So 0 is equals to, this will be a over 3 minus 3. Transpose this to the other side. We have 3 equals to a over 3. And then for me to get 3, then I can cross multiply, and my a will just give me 9. Then I go back and say, my g of x is equals to 9 over x plus 2 minus 3. We have found our equation of g. Yeah, so this is what we can go as far as today to actually push you guys in the right direction. Please, the rest is just going to be your inverses. We have done that, I know. Just go and remind yourself, and then use previous question papers. I'll be available almost until 10:30. So if you have any questions, please do ask them on WhatsApp. You can send me a personal WhatsApp. If there's any questions on the video on our YouTube channel, you can just also screen grab that part and then send it to me, and I'll also assist. Because it's now 10 minutes past 5, so we need to depart, unfortunately. Thank you very much, those who watched. Thank you very much. Let's continue. All the best for tomorrow. Good luck. It is not that bad. And make sure that you also rest. You must rest. When it's 12 o'clock, sleep. Write what you know. What you don't know, you don't know. But do your best. Yo. It's chai.